Hello everyone. So my name is Tamer. I'm a principal engineer at Bitspire, and today we're just sharing with you our production experience using Pulsar in Chatroulette project. And part of it was started like February this year, early this year, and they were trying to rebrand and trying to build a new platform. And this platform, they needed message queue at the core of it. And at the time, they were looking at Kafka. And when I joined the project, I recommended just to look at Pulsar and just to use Pulsar. And we have been running Pulsar in production now for over 6 months. And we used actually in few different use cases, which we couldn't find many documentation in it online or many production experience online. So that's why we want to share our story and share our experience. So the presentation will be two parts. My part will be recorded, and then my colleague Gabriel will have his part live, and there will be around as well for answering questions. So this is the first part, which is the recorded part. In this part, I'll be focusing on the use case, the business use case, and then the architecture, and then how we used Pulsar in production. So I will share with you some numbers from production. And then the second part will be mostly focused on the code and how we develop some open source libraries to work with Pulsar. And so just to give you an idea, if you don't know like Chatroulette, so they are known by connecting people online, and recently they are going through different rebranding effort and adding new use cases, business use cases. And from February this year, we started working on this new platform. And to give you an example of one of the project we had in production, which was running on Pulsar as well, is Scale by the Bay. The famous conference was a few weeks ago, and they used Chatroulette actually for connecting attendees. So why we needed really Pulsar or message queue? So first, the system was just a giant monolithic application, single instance, was hard to scale. So, and with COVID, the demand increased actually. So we needed the new architecture, a new platform. So that was the first reason. And the second, as I mentioned, like because of COVID, like the production is getting more and more requests. So we are getting around 6 million daily connection. We're making 6 million daily connection between users every day. So, and before it was just for online connection, but now we are adding more use cases like using Pulsar, using Chatroulette, for conferences and for Teams. Also, we wanted to have a strong analytics pipeline to be able to have unlimited data, all the events we need. So we needed to build all of these use cases. And for sure, we needed the message queue and the data pipeline to have all of these use cases supported. And that's why we were looking at Pulsar. So this from Kafka to Pulsar in 30 minutes, it just reflects how long it took me to convince them with switching from Kafka to Pulsar. And literally just 30-minute conversation. And this is I saw it over and over with many different startups. And really it comes to the main like advantages that people are looking for. You need the same low latency pub subsystem and flexible subscription model. So you can have sharded subscription, you can have queue semantics. So that's one of the very like first reasons that people want to move from Kafka to Pulsar. Second was really a big one because of the architecture of Pulsar, separating the storage from the compute and having the segment as the smallest piece of storage. It's really easy, much easier to run. You don't need to balance topics, don't need to have a dedicated DevOps team just to run Kafka in production. So that was a very big reason, because the team is really small. So you need to really leverage the easiness of running Pulsar in production. Third, the ephemeral topics, which is really helped in the architecture on re-architecting the system, because it was very easy and cheap to create topics on the fly, and then they will be cleaned automatically. We were able to build the architecture around this feature actually, and that was one of the main reasons we used Pulsar. Second, Pulsar function, for sure, it was a big reason, because we are running on bare metal, so we don't have like the Lambda, so we wanted to have this similar semantic of Lambda and serverless. So Pulsar function gave this to us. And finally, the tiered storage, which is, I will discuss it more in details coming, but it's mainly helping us to have this infinite storage without having our application to deal with different interfaces. So the application is abstracted against Pulsar, and regardless of where the storage is. This is just a snippet from production. This is took a few days ago, and this gives you the current environment you are running. We have 3 zookeepers, 3 bookies, and 3 brokers, and this is the current of traffic we are expecting every day. So our throughput is around like 25 megabytes per second, sometimes peak more or less, and we are getting more than 2,000 messages per second, all the communication within the cluster. And we are running the latest 2.61. There is 2.62 now, so we will upgrade soon. We just run single instance of proxy because we're really running on Kubernetes, so we don't need the proxy. So the discovery is done through Kubernetes. So we just run the brokers, bookies, and zookeeper. And the storage we retain messages like 250 gigabytes of storage for analytics. So this is actually giving you the current configuration we are running. Each broker is running with 8 to 16 gigabyte of RAM, each assigned 4 cores, and we have 3 brokers as mentioned. For the bookkeeper, we give it 4 to 8 gigabyte of RAM, and actually this will be different from the use case, because in our use case we are using mostly for communication between services. So only for analytics we need persistent topic. Otherwise we just use non-persistent topic. That's why we don't need much memory in the bookkeeper compared to the broker. And this is zookeeper, just 2 gig of RAM, 2 cores, and everything running stable. So that's give you like the top messages, the around message rate 2800 messages per second, and around 25 megabytes per second the throughput at peak. So this is just kind of the production environment you are running, and we have few things, like it's all running on Kubernetes on bare metal, and we use Istio actually under the hood. So all the networking communication Pulsar is installed on top of Istio. So, and that was some of the things like we couldn't find it online. So we are sharing this experience because it's working very well on top of Istio, and we can leverage some security networking from Istio. So all the components, zookeeper, bookkeeper, broker, all the Pulsar components are running on top of Istio. So, and for storage, we are using Ceph because again, it's on-prem. So we're having a dedicated storage cluster with Ceph, and it feeds all the persistent volume for all the components. So zookeeper and bookies, all taking the volumes from the Ceph cluster. And that's actually one of the big things. So the use case we are having is mostly dependent on having so many ephemeral topics. And at any given minute, we have over than 20K ephemeral topic for all the communication. So that's the kind of workload we are using. And this is our production environment. So I will just jump quickly on the architecture just to give you an overview how we use Pulsar. So we have, this is the client side. We are getting events all the time from browser or mobile phones. And then we have 2 different sort of namespaces or 2 different use cases. The first one on the top here, services. So services is mostly the microservice communication. So all the microservice communication is going through Pulsar. There is no point-to-point communication. So all the services and everything is required low latency. So all the services communicate through Pulsar. And then we move this data. So some of these events we needed for analytics. So we have 2 sources of analytics events. One coming straight from the consumer, from the web browser, events from interaction with the system, and some events coming from the back-end microservices. So both of them end up into a different namespace for analytics, and all of these events will go through validation, which is like a Pulsar function, and this will validate the event, make sure it's formatted properly, and we'll put it in another queue. And then from there we just either have some rollups, another Pulsar function, or we just right away write it to the sink, which is at the moment we are using Postgres with TimescaleDB. So that's our sink for all the events. And this feeds a dashboard. We're using Superset and Grafana, so both of them feed the dashboard. And that's sort of the high-level architecture that's currently running, actually most of it running currently in production. And I will come again to this key value store later. So what the use cases we're using? First, microservice communication. So all the microservices communication is going through Pulsar. There is no point-to-point communication at all. And we have request response pattern. And actually for this, because of the state, because most of our server, actually almost all of our services are stateless. So having a per user topic was very, very critical for the architecture. So we create an ephemeral topic for each user, and it will carry the request response for this particular user. So all of this microservice communication through ephemeral topic is running on top of Pulsar. That's what I mentioned now. So ephemeral topic was really one of the big reasons we picked Pulsar, and it's working pretty well. So it simplifies our architecture. And compact topic. So we have very interesting use case. So sometimes we need to keep the latest value for every user. Let's say the latest image for every user. And first we consider to use like key value store, but at the end we figured out that we can just simply using a per user topic with compaction. And actually it worked pretty well. So instead of using an external key value store, we just save the image with TTL and with some retention. And then if anyone need to get the latest image for this particular user, they just pull it from their compact topic. And finally, the analytics pipeline. So all of the events that coming here, we're using Pulsar function. So we have a window function that will aggregate all the events within, it will batch them within 1 second, and then we'll store it in TimescaleDB. And like our throughput, it's above 500 insertion per second. So that's roughly the throughput, and the database at the moment is like almost 500 gigabytes. And also all of this through Pulsar. So I'll just share very, very quick lesson learned, what we learned from our experience running Pulsar in production. First, ephemeral topics, producers and subscribers scales pretty well. So we create, because we're using functional programming, functional style, which Gabriel will cover in the next presentation. So we create all of them on the fly. So we create the subscription and close it, create the producer for ephemeral topics. And actually it worked pretty well at scale. So we can create them, as I said, 20K topics per minute at any given minute. And that was big surprise because we couldn't find any case study before this. So that's what we wanted to share. The second lesson, which is when we started using Pulsar function, we wanted to use it also for routing some events. But because of the ephemeral topic and because the nature of Pulsar function, it didn't really work well. So we actually opened the ticket for it, because Pulsar function doesn't allow you to control the producer. So they will keep opening producer for ephemeral topic, but this producer will not be cleaned unless you restart the function. So after some time, it works well, but it will keep accumulating this. It will prevent the ephemeral topic from being cleaned up because the producer will keep it open. So, and that's actually, it will be, I believe it will, in the next release, it might be fixed already. So after we started with the Pulsar function for this routing use case, then we couldn't continue this in production. So we had to go back to the regular service, but we're still using Pulsar function for analytics. That's another use case we had. So because we are passing images between the microservices, so first when we started the architecture, we had the images being stored in a blob store, like S3 compatible, like min.io or Ceph. And then we just pass the URL for this image into the Pulsar message. Actually, because of the scale and the high throughput and like high I/O operations per second, we had a problem with this architecture. So what we ended up doing is we actually dropped completely the object store, and we just used Pulsar. So the message is quite small. It's around 40 to 50 kilobytes image. So we actually pass it directly in Pulsar message, in the payload itself. And it worked pretty well. It scaled. It was very, very stable. And we have now, so without using the Ceph, for example, now we are getting around 200 to 300 I/O operation per second. But in the previous architecture, we used to have 10,000 operation per second, which is very hard, like very bad for the disk. So this was a very good use case. So we're just passing the images directly around in Pulsar. Pulsar window, we're using Pulsar window with 1 second duration for analytics. So it actually scales pretty well because you can't keep inserting individual records at that scale. So we just batching them with 1 second, so we still have near real time. And the Pulsar function just accumulate all the events coming within 1 second and submit them in one transaction to the database. And it works very, very stable. And that was another lesson learned. Running Pulsar on STU works. When we started, we didn't manage to get it to work with STU, but there is just one configuration you change in Zookeeper, and then it ran on STU, and it's running stable on STU. So we can get more visibility on the networking. We can add more security, partitioning, using from STU. Also, we are running the bookkeeper persistent storage on top of Ceph, remote Ceph. It's a dedicated Ceph cluster, and it's working pretty well. So we could optimize more by running only the journal on a local disk and then the ledger on Ceph. But for our use case, because we don't use much persistent storage for the real-time communication, we just use it for analytics. So it's working pretty well and scaling very well. So we didn't have any problems of running on top of Ceph. And finally, the tiered storage, actually, we have a problem of small files because we have so many small images and it accumulates quite a bit, like hundreds of gigabytes and terabytes actually. So what we do is, instead of just storing the individual image, we are exploring now actually just store it as a message in Pulsar and use a tiered storage to offload to the object storage, like Ceph. In that case, the offload will be a big file, but we still are able to scan and access the individual images. So that's another thing. We are actually looking into it right now. And with that, so I will leave it for Gabriel to take it from here. He will be live, and Gabriel he's a functional programming guru, so he will take you through the code and the open source libraries, and they'll be around for questions. Thank you.
Everyone, yeah, thanks to my colleague Tamer for introducing the architecture of our system. I think it's a pretty interesting use case. But now for the second part, it's like a completely different topic, but somehow related. It's the other part of the work that we do at Chatroulette. It's the open source Pulsar clients that we have published in our GitHub repository. Are called Neutron and Supernova, just following the scientific names of the Apache Pulsar. And Neutron is the one that we actually use in production, the one that my colleague Tamer was describing in the architecture. We write all our backend services using Scala in a functional programming style. So that is the main library we are using. It is built on top of the Java client, the official Java client for Pulsar. And there's another one called Supernova, which is an experimental Apache Pulsar client for Haskell. It is not currently used in production. It's pretty much in development, and I was the only one developer doing that. It's like being made mainly for fun, but because we also had the idea of introducing Haskell in production. And then we have this Pulsar demo, which basically showcases how we can integrate Neutron and Supernova on creating a few consumers and producers, and how both applications interact with each other. So the idea today is just to get it's just to showcase how this Pulsar demo works, and just to show you a little bit of the code necessary to run, to create a consumer, to create a producer, and to get it all working. So first of all, we need Apache Pulsar, of course. The easiest way to get started with it, it's using Docker Compose. So in the demo, there is a Docker Compose file. So if you just run Docker Compose app, you'll have an instance of Pulsar running in a few seconds. And on the other hand, we have the consumer, which is written in Scala using the Neutron library. And this is the command we run. We do spt run, and it is going to start up a Pulsar consumer, and it's going to wait for 2 messages and then finish. And on the other side, we have this producer, which is written in Haskell using the Supernova library. And you can see, like, if you are familiar with the Pulsar protocol, all these messages that are in the back level, they represent the protocol itself. All this definition of the protobuf. Yeah, this has been a lot of fun to work with. I'm going to talk more into details about that when we get to the producer. But this is the whole idea of the last part of the presentation: writing a consumer in Scala using Neutron, writing a producer in Haskell, and have them communicate with each other using Apache Pulsar. So for the Scala part, using the Neutron library, we first need a bunch of imports. Don't worry if you're not familiar with the language. I'm pretty sure you will understand the concepts that are related to Pulsar. So this is how we create a configuration, a topic, and a subscription. I guess all of this makes sense even if you don't know the language. But one interesting thing, I guess, like, if most of the audience might be familiar with Java and with the builder pattern. If you use the builder pattern in Java, this is pretty similar, but this is using a different technique, which is called type level programming. And basically, if you forget to pass a name or a type of something that is required, this will give you a compile error. Your code won't actually compile. So this is pretty neat. I think this is one of the nicest features of the API we created. And it uses a technique called phantom types and type level programming, if you're familiar with that. But like the thing is, like, the users don't need to worry about how all of this is implemented. The nice things is that they benefit from the type safety of the library. So there is no way you can create a malformed topic or a subscription. So that's how it looks like. And for the other part, we create a record, or in Scala it's called a case class, basically a message with a name and a year, different fields of string and integer. And then we create the Pulsar connection and a consumer. This is represented as a resource, which is going to manage the lifetime of both the Pulsar connection and the consumer. So this is a pure value. There is nothing running yet. Because this is functional programming. Instead of like dealing with statements and we tell the computer do this and do that and then do this, like there are only definitions of pure values. There's nothing that is running yet. So these are just pure values, like an integer, for example. This is just a construct. There's nothing happening yet until what we call the end of the world. And this is our run method. This is where we start composing all of these small functions and running this stuff. Don't worry about all the stuff here. All you need to know is, like, we are creating the Pulsar connection and the consumer, and we use this auto subscribe right in the middle, which is something we created in Neutron, which we find useful in our code base. It's basically create a subscription, subscribe to a topic, and then auto-acknowledge the messages. Basically, whenever you consume the message, you auto-acknowledge. So it's a combination of subscribe and auto-acknowledgement. And that's it. Whenever we receive the messages, then we interrupt the stream, and we finish. One nice thing is, like, the Neutron library is built on top of FS2, which is one of the best streaming libraries in Scala. And I think it fits very well the message broker pattern, where, like, I see everything as a huge stream. Like, you have message coming in different topics. You can combine them in different ways. You can have fan in semantics, fan out, merge different streams together, and it all flows together in a nice way. So I think it really fits the pattern of using a streaming library for this. So that's why we base the Neutron library on this library called FS2. So that's it for the consumer. I think the consumer creation is always a little bit more difficult because it requires creating a subscription and manage that subscription and acknowledge the messages. The producer, on the other hand, it's much easier to set up. So a reminder, this is how we run the consumer, basically using SVT. It is the standard build tool for Scala. SPT run, it'll start the consumer, and it'll consume these different messages. On the other hand, we have a producer written in Haskell. This is how it looks like. A few language pragmas at the top, a few imports needed for our program. But the important thing is at the end, we have our definition of the record type. In Scala, we define a case class message. In Haskell, we use this data keyword to define a record, and with basically the same fields, name and year. And we have a way, if you see this from JSON to JSON, a way to serialize and deserialize this record into the JSON format. So once we have this, like all we have to do to create a producer is this piece of code on the right-hand side. We create a topic, and then the main function basically does create a connection to Pulsar using this connect. We did the default connect data, so this works in localhost using the default Pulsar port. Then it creates a new producer using the demo topic, and it basically sends these two messages defined at the bottom, which is a construct of these two records that we have, and basically calling the encode function, which will encode this Pulsar message in JSON format. So this is how the API looks like at the moment. It works. It's still not perfect and experimental, so I wouldn't recommend the usage in production of this. But yeah, if you want to give it a try in some small projects, then I think the use cases work pretty well. There are a few other examples in the documentation that show how to also run a consumer and a producer together, or multiple consumers and multiple producers in the same application. You can run them concurrently. That this is one of the strengths of functional programming, that concurrency and parallelism are explicit and are really made easy. You can reason about concurrency in a very easy way. So this is how we run it. A reminder, cabal new run basically establishes the connection with Pulsar, and you can see that it creates a producer. These are the protocol commands. If you're familiar with the Apache Pulsar protocol, we can see the send message here, that it's an outgoing message, and then incoming message send receipt. So we send two different messages and we get two different receipts. And yeah, so in the end, we have a small Pulsar demo that runs using the Neutron library and the Supernova library and interacts with each other using Apache Pulsar. I think this was a great experiment and great work, and understand, like writing the Supernova library was very cool to get familiar with the Apache Pulsar protocol and with all the details and how it looks byte by byte at the wire level. So it's been very interesting. So I hope we can get more use of it in our system probably early next year. So that's all I had. And I'll be around if you have any more questions, or like about the architecture. I could answer whatever I know. I'm not the expert, but if you want to ask me any questions about what we do at Chatroulette, how we use Apache Pulsar, I'll be happy to answer them. And yeah, thank you. And xianxie, is it Mandarin? So yeah, thanks for listening.
Okay, thank you, Gabriel and Tamer, for your talk. It's really provoking, and we learn how you use the Pulsar at your company. And thank you very much for your talk at our summit. And thank you for
having us.
Okay. We have another session. Maybe we can just exit this one and continue the new one.
Okay, I should just click on leave, right?
Okay, bye.
Okay, bye. Thank you.
Yeah, bye.